Hi there, and welcome back to the channel. In today's video, we're going to take a look at something that I don't talk about often on this channel, and that is the observable macro. Now, the reason I don't talk about it much is because it's just a macro, and we can use it in SwiftUI to allow our views to observe properties on our view models or whatever you've marked as observable. However, it would be nice if we could use the observable macro inside of any object instead of just a SwiftUI view. We can certainly do this with observable objects, so hopefully the observable macro provides similar functionality that would allow us to observe individual properties and react to changes. If you like learning about these kinds of things, make sure that you hit the subscribe button because I talk about a lot of cool Swift stuff on this channel. So subscribe, hit notifications, like the video, do all of these things so that you get notified when I upload and so that others will see this too. Okay, so in this video I mentioned we're going to talk about observable and observing individual properties. Now, there's several ways that you can do this, and there's several reasons why you would or wouldn't want to do this. In this video, I don't necessarily want to focus on the why do you want to do this, or there are a million other ways to achieve this, and more on can we use the observable macro to observe state outside of a SwiftUI view. So it's more of a theoretical exploration than me wanting to apply this in a real world situation. So with that out of the way, let's take a look at some code and see what we start off with and what we can do, and then we'll talk about other ways to achieve our goals and why it might be really hard to do what we actually need to do. Okay, so what I've got here is a simple command line application written in Swift, and the goal is we're not using any SwiftUI, so how do we now do what we need to do without SwiftUI and without any problems, essentially? So this code has a main struct, a main function inside of that struct, and a counter. Now, this counter is going to change value over time, right? It's going to change from 0 to 1 to 2 to 3. Create an observer object. That's the object that we'll use to observe that counter. We'll have an observe function in there to kick off our observation needs, and then we will actually change the count, wait for a second, change the count again, wait for a second, and change the count again. We're going to add a will set to our counter observable so that we can actually see when we change things. Let's get rid of this, we don't need that right now. And let's go on ahead and add a will set here, print will change counter, and we'll also do a did set. Why not? Print did change counter. I can run this already, and we'll actually see that we get a will and did change for every change that I make. Right, so that's pretty good. Now, what we of course want to do is observe this count from outside of the counter. Right? Will set and did set on an observable's properties are great when you need to observe these properties inside of the class itself. Right? If I wanted to be notified of changes inside of the counter only, I wouldn't do anything past this point. I would implement a will set or a did set, and I'd call it a day. But in this case, I have my counter observer here. And that counter observer is just a plain class. It's got a let counter. It's initialized with our counter. We assign it, and then we have our observe function. And we'll use that observe function to observe changes to our counter. So what we essentially want is to receive a print when the counter changes its value. The observable macro introduces an ability to do that using withObservationTracking. So I can use withObservationTracking. This takes two closures, apply and onChange. The apply closure is where we access state, and onChange is called whenever the property changes. So what we could do for our apply closure, just print counter.count, and maybe we'll do something like count is, print that. And now, because we accessed counter.count inside of that apply closure, the observable macro knows, or our model knows, that we accessed count. And so whenever count receives a new value, our onChange is going to be called. What we'll do here is inside of onChange, we'll just call observe again. So whenever this property changes, we want to reset our observation. I'll explain why we need to do that in a moment. We need to explicitly capture self. We can do that. And there we go. Now, this already is an interesting output. We immediately get count is 0. That makes sense because we called observe and that apply closure is run immediately. Then we see another count is 0. That's interesting. Why is count 0? We'll talk about that. We then see will and did change, then count is 1, will and did change, count is 2, will and did change. This tells us that our onChange is essentially called before the value of our counter is changed. Right, so we access the count is about to change, our onChange gets called, then our will change is called, and then our did change is called. So when we access the value here, we actually see the old value rather than the new value. And that's no good. Because, well, if we are SwiftUI, that's great, right? SwiftUI wants that will set semantic, but we want to get the new value. The way to do that is actually a little bit tricky, or counterintuitive, I'd say. We need to postpone our access to the next run loop. A common way to do this is to use dispatch queue.main.async. This will schedule our print to run, but it will run it on the next run loop. So we'll need to do this, self.counter.count. And now things got really weird somehow. So this probably was not what we wanted. How about if we put the dispatch queue main async here in the onChange? Because a couple things seem to have gone wrong here. We printed 1, and then we never printed again. So let's try this. That's much better. Right now we access count synchronously, immediately. When something changes, we call self.observe on the next run loop. Right? So then we get 0, 1, 2, 3. These are the outputs that we want. This isn't necessarily great to write every single time. So if we look at the Swift forums, there's a lot of people that want this, right? They don't want to be notified when a value will change. They want to know when a value did change. So if we take a look at the forums and sort of what people talk about there, we can actually see that this is a topic of debate, right? There's a lot of responses here. A topic started in September 2023 and it ran all the way through until even 18 days ago at the time of recording this video, which is early 2025. So what's proposed here is a function with continuous observation of value. Now, this implementation, as the author says, misses cancellation. Not a huge deal, but it's also not great. But we can take this and work with it. Notice that in this example, the author chose to have an auto closure and to have a generic that returns, and it's all a bit complicated. We can actually make this somewhat simpler. So let's take a look at my version of this. And this is by no means to say that my version is really good. It's just a simpler syntax of something that is missing from withObservationTracking. So what I'll do is I will add a custom function here, public function withObservationTracking execute. And so that execution closure runs, and then we call withObservationTracking again on change. Quite simple. Note that I had to make this closure sendable. We'll talk more about that in a moment. It needs to be sendable because on change with observation tracking requires us to use a sendable closure once we find ourselves needing that with Swift 6. Okay. Let's use this and see what the result is. So we'll use withObservationTracking and we'll print our count like that. And that's it. This works and is great. The choice Apple made with observation tracking is that it's sort of really easy to write a memory leak here. Let's change our code in main a little bit so that counter observer becomes optional. And after we've sent our second count, I'm going to set the observer to be nil before we change the counter to 3. And ideally, we don't receive anything at all because we're not even there anymore to listen, right? When this object counter observer goes away, what I want to happen is that we no longer print any counts that come in after I've been set to nil. So let's run the program and see what happens. We get 1, 2, and funny enough, we do get 3. We can actually confirm that this object got deinitialized, or rather, whether it got deinitialized by printing dinit. And we'll actually see that the object never got deinitialized. So that's a bit of a problem. Luckily, because of how this was set up, and this is why I chose to not use the auto closure from the Swift forum, we can use a weak self-capture here to quite easily have some form of cancellation. So what I'll do is I'll capture self weakly like this, and then I'll guard let self equals self. So now, when we don't have self, we don't access anything, and so we don't print anything, and that also means that we're not notified of subsequent changes. I'll admit it's not perfect, it's not fully there, there might still be issues with this, but at least we have some form of cancellation, and we'll have self dinit at some point, which is really good. So far, we've actually been able to use the observation framework to observe state changes to our counter without having to use a SwiftUI view. So it's pretty good. We managed to reach our did set semantics so we can access the actual current value by using a dispatch queue main async, which I don't like much, but it is simply what we need to push our code to the next run loop. So what happens when we use Swift 6? Because the module we've been working at is a Swift 5 module. Once we go down the route of Swift 6, things change a little bit. Let's see how. So I told you about needing that sendable annotation. And what I'm actually going to do first is change our package so that it becomes a Swift 6 package. I'm opting out of the Swift 5 language mode. So I'll run this code, and we immediately get a failed build. The error is capture of self with non-sendable type in a sendable closure. So what we can actually try and do is make that closure not sendable. I just remove the sendable annotation here and see what happens. Now it says capture of execute with non-sendable type in a sendable closure. So basically this closure that we pass to dispatch queue main async has to be sendable. So because of that, I need a sendable annotation here too. Right? Unfortunately, not much that I can do about that. Now our issue is that capture of self with non-sendable type counter observer. So what we need to think about is how could we make our counter observer a sendable object? And one thing that you might want to do is main actor annotate it. See what happens then. Now we're getting complaints saying main actor isolated property counter cannot be referenced from a sendable closure. Right, so now our counter instance is isolated to the main actor because of our class being isolated to the main actor, but our closure body here does not run on main. So that's a bit of a problem because this closure also isn't asynchronous, so we can't just access this from anywhere. We could maybe annotate this closure with main actor, but now we get a call to main actor isolated parameter execute in asynchronous non-isolated context. So we're really just shoving this problem around, and things don't necessarily become easier at all. So unfortunately, I find that when I want to use Swift 6, the observation framework just kind of falls short here. There's no trivial way to get what I need, which is those did set semantics, without running into various sendable issues. And sure, there are ways to eventually get it to work. But at this point, I chose to more or less give up and decide that for state observation in a Swift 6 package, I might prefer to use combine and publish properties. These just simply seem to work a little bit nicer, seem to be a little bit further done, and hopefully Observable gets there, but I think we'll have to wait until June and iOS 19 until we see it get there. I hope this video taught you a couple of things about the Observable macro. Mostly that if you're using it in SwiftUI, it's really good. I have other videos on that, so make sure to check that out. If you're using it outside of SwiftUI, you might run into issues. It might be fine for you. You might be willing to work around the sendable issues and eventually get things in a place where they work, or you might be more like me and decide that combine is still what you would want to use in a specific situation where you don't want to use SwiftUI around your observable object. So if you like this video, make sure you subscribe, and I would love to see you again in the next one. Thanks for watching.